it relates to robotics completely because robots are complex systems,
Yeah.
So yeah, I don't think I can put it in words right now, but there's something in like I feel this relation, and I think it has application over in our field as well.
Yeah. Complex systems need systems engineering for sure.
Yeah. So that's something that I wanted to add to the article in the final stages. But I mean, in the last part, I don't know if you've gotten through there yet.
Yeah,
But
I read that last paragraph there, a couple paragraphs.
yeah,
Or that could be a different article.
yeah. I just had something on my mind, so I had to put it out there, like in words. So I did that. Usually, I get some time on Wednesdays to work on like my several writing projects that I do, or any of the writing that I need to do. It happens on Wednesdays. So Wednesday was I got like 2 hours straight. I banged it out. But, yeah, I would love to have more input from you on there if you got like what do you think, and how can I improve, and what other things that I should take care, because this is my first time writing something like this. I did a small thing about the math work seminar, but it was all my experiences, and this is something more technical, so it has different implications than the other one that I did. So I can really use some help here.
Okay. Yeah, I got some time. I can take a look at that. It may be tomorrow, but I'd like to look at that and get those articles out for you before ROSCON starts.
Yeah, that would be great. I also saw someone emailed me about Roscon, so because it's almost a week before it, so
Yeah.
I'm really excited about it. But I also heard, read there that there's gonna be flash talks or something. It's like
Lightning talks.
lightning talks, exactly. 3 minute, you get 3 minutes to present. So I was thinking I'll do something about it, and over the week that I have before Roscon, and then I'll try to present, because there's a committee that sits before, like, so the applications for those lightning talks open at 9 a.m. on the day of the like on the day of the convention,
Hmm.
uh, and then the committee decides who gets to speak. So
Last
both
year
the
it was
days.
a lottery.
Oh wow, yeah, it's the same. Oh,
So we filled
okay.
out their names and then they went into a hat and then they drew who they wanted for the
Oh wow,
lightning talks.
interesting.
Yeah,
Yeah.
there was like 5 spots and 20 people entered. But
Oh wow.
we'll see what they do this year, how much time they
Yeah,
allot for that.
yeah. I don't know, but I'll try and do something. So
That's
I get
smart.
to.
You're
Yeah,
preparing ahead. Get
yeah,
a 3 minute talk together. That'd be great.
yeah.
And get your
I mean, I think 3 minutes is too much still, but I can. I think I can talk for 3 minutes, and you know, just try it, because I've never given a talk or something, so it would be an interesting thing to do.
you bet.
So
That's good thinking.
yeah, but yeah, I'm really excited about Roscon this time. Yeah, it's gonna be fun, and there's lots of new things to learn there.
Yeah, a lot of people.
So yeah, that's what's up on my side.
Awesome.
So Al couldn't make it this time, this meeting, so uh, I don't really have anything to present. I will ask Sohin, since he just got a TX2 eval kit. Have you tried to use the CAN bus on that device?
Uh, I have the TX1 set up and working. I got the TX2 yesterday. I unboxed it. That's it. That's all I did. So, no, I haven't done anything with the CAN. I don't think we have enough application. I mean, we don't have anything to work with the CAN right now. But I mean, I can try and see what, like I can try and replicate if you're having any errors, since I have the board with me, so I can help out that way. I don't have a specific application for the CAN bus. Uh, we just got the TX2 because we had a small robot, and it had the Navio on it, so I didn't want. I mean, I suggested that we're gonna have some more people working on it, so for next year. So I suggested them to just put a TX2 on there because it's almost the same, and you know the university had money for it.
And actually, I'd forgotten that you started with the TX1. It turns out the TX1 does not have the CAN, but the TX2 does, I think.
Right, you're right.
And the other thing is, I have a TX2 laying in a box over here, but nobody's hooked it up or powered it up, so I don't know if it's got software loaded on it or if that would be a full day to try to get it to run.
It's pretty easy. It's really cool. NVIDIA has done some great work with that. So all you need is like a Jetpack software on your computer, and then you hook it up with the micro USB port on your computer, and then it's like a Windows program. You set it up like next, okay, and you're all set. It takes some time, and it comes up with Ubuntu, and it comes like you get to check, like it's just if you want TensorFlow or something on it, you just check mark that and it's going to be on there. So that's pretty cool. um, and then with ROS, like if you want to install ROS on it, I think Jetson Hacks has a nice ROS code, so it's like a single line install on the NVIDIA. So pretty neat. It takes like an hour to set it up and working. But all you do, like in terms of commands, is like 2 or 3 commands, and you're fine. So.
Okay. I know the previous one, the small one, the TK1, I know you could take that out of the box, put power on it, and it would talk to you directly. It had some kind of their version of Linux loaded on it. So I didn't know if the TX2 and the TX1 are set up that way now. And probably if I'd ask here, somebody may know if they've played with it. So
I think it comes with a pre-installed Linux, but then it's always better to reinstall with Jetpack, and that's what they suggest you to do. So so that you don't, so that you can get all the packages that you might need, like for AI development. So I'm sorry. Yeah.
My first objective was this guy, I think he's in France, and he's trying to get his CAN to work on his TX2. So I don't really care if it has all that extra stuff. If you get that far, I just plug it in, hook up transceiver up, and see if it get it to talk. So that I might be able to do that quick enough to be able to get around and try that.
Yeah, I don't have any CAN tools or the CAN analyzer or anything to check that. I saw that post, but I felt, I can't really help with that. But I have the TX2, and I don't know if you want me to replicate something, it would be possible. It might be possible. I might not have all the CAN tools that are needed to hook it up, but.
I was just curious if you'd played with it enough to know, give me some advice on if I should proceed or not. So,
if you want to get it working, it's always cool to have a nice system working. So, and that's easy. That's just 1 hour job for you. Like, the only time it will take is the download time. That's it. There's not much to do over there. But and then I think my university is also considering buying the AGX, the Xavier. They're giving it away for $1,300, and they just launched it. And then someone, I think Fetch Robotics, announced that they're going to use that for all of their robotic arms moving forward. And then Audi launched an electric vehicle, and they're going to use NVIDIA Xavier. So interesting stuff is happening with NVIDIA.
Yeah.
They're going big.
So does anybody else have anything going on? Matt, how's your garden tractor coming? Have you done any more on that, or you?
I've started playing around with robot localization. Basically, I've got a couple GPSs, but this is like a $35 GPS. Just get it from Robo Hub or Robot Shop. It's that one. I guess it's reverse. You can't read it, and then just the Razor IMU, and then the wheel encoder. So right now what I'm trying to do is get this one. This is just a Raspberry Pi that has robot localization running on there. And so the thought is I've got a Raspberry Pi on the Lawntractor. I'll keep that one sort of as the brain, or the listens to the move base control and then controls the motors. And then the GPS system or localization system will have its own little Raspberry Pi. I did get this working, and it was only, there's 4 processors on the Raspberry Pi, and with robot localization running, it was only taxing 1 processor at 60%. So I think that there's enough power there to read sensors and to log data and provide localization.
You also had a laser scanner that you were going to put on at some point, didn't you? Okay.
Yeah.
Okay.
And that would be the next phase is to add GPS denied navigation, so be able to switch in between laser and GPS.
Okay.
Not working yet.
So Colin, you want to give us an update on what you're doing? You were taking classes and playing with development kits?
I don't think your mic is on.
Yeah, I can't hear you either.
You can't hear me. Right now?
The volume's low.
Let me see. I checked it earlier on, and I'm sorry. It looks like everything is fine. I don't know what the problem is. You still can't hear me. You can't hear me at all.
The sound is very low, Colin.
I'll speak next week then. I can hear you clearly, but if you can't hear me, then I will speak next week.
You could try to log out and log back in, and sometimes that helps. You get a better connection. I don't know if that helps or not for everybody, but it helped me a couple of times.
Yeah, that's a good idea. Let me try that. Once. It's okay. You can proceed, guys. You don't. I'll try to see what I can.
Have you gotten the that simulator to work on the Constructor, the RDS, robot development?
Who are you talking to? Me?
Anyone? Yeah, anyone. If you were able to get that working.
I haven't got it to work yet. The first time I tried to go in, it wouldn't The very first problem was it wouldn't let me in anyway. It said all the old stuff had been deleted or something. And then that got updated, and I'd click on the thing and say, go into the studio, and it has like 4 or 5 steps it has to go through, and it would just sit there and do nothing. Yeah. And I finally realized if I sit there for about 10 minutes, it'll finally let me into that. So I finally got into that, and I was going to try to do the steps of copying the files down to my computer. And that's why I realized my hard drive is out of space, so that set me back there. So I looked at it, I just had to expand it. For some reason, I'd only assigned 100 gigabytes to my Linux partition. The rest of it was all free space. So I was probably intending on adding Windows or something at one point. So I expanded that out. I got plenty of room now, and I just have to get time to get back and work on it. So maybe tonight I'll look at it, or maybe sometime this weekend I can try that again.
This is right where I got to. Oh, no. I have it working on the remote, but I don't have it working locally. So I guess that's where I am, trying to get it working locally.
So I guess my approach will be to try to get, number one, try to get Gazebo running locally, and then try to get, say, Husky running locally, and then move on to the this extra waypoint stuff where it seems to be the holdup. And it seems like, you know, the Husky stuff seems to be documented well enough that you should be able to download that and say execute, and you should be able to get a system that runs. And so I just need to go through the steps and try that out and see what works and what doesn't work. And I've been around enough times now that maybe when I run into some of these problems, I can track them down to figure out why. You know, like Al was running into a problem that said it couldn't find the Husky description or something, and you know, since I didn't have it loaded, I couldn't really look at that to see what that was saying at that point. But hopefully, you know, once I get something running, then it's easier to track down why it's saying these things. And
yeah, on that video that explains how to download the RDS project onto your local machine, you know, they suggest doing that ROS dip install, and they make a comment that if not all of the build dependencies or run dependencies are listed in the CMake, then it won't install those. So I didn't know if using ROS install or using some sort of a bash script to make it easier to install that package or install a final package. I mean, if we move away from using the Husky to just some sort of like block cart Ackerman model, then what is a good approach to bundle all that together to get it an easy install on somebody's computer?
yeah, it seems like once we get it all figured out and running, then you'll know the steps up to that point, and then we could put it into a script or something. But you know, when everybody's still just poking at it, trying to figure out, you know, why doesn't it work and why it says it should work but it doesn't, you know, we have to figure out why to get past that first. So on a couple of related notes, they said that RDS had switched over from Gazebo 7 to Gazebo 9. And then I was running into those problems with Gazebo 9, and the guy that works at Gazebo has it fixed. So if you load the 9.4.1, which is now the latest version of Gazebo, it fixes at least that. The problem was when you'd shut down Gazebo, it would leave something running in the background, and you try to start it again, and it wouldn't start up. Well, that is now fixed. So if you just load up the Gazebo 9.4.1, that fixes that.
Okay, awesome.
And I found an easy way to do that. I like to use Synaptic Package Manager, so that they used to supply that by default on Linux, and I don't think they do anymore. So you might have to go out to the command line and load that, or you can go to the Ubuntu Software Center and say load Synaptic. But that will, it brings up a screen, and make sure you click on the thing that says reload, so it gets the latest list. And at the top under search, if you just type in gazebo, it shows you every instance of gazebo that you have or you could load. And it shows you what your current version is, and it shows you what the one you could upgrade to. And it also lists all the ones that are associated. So there's like 6 different packages it wants to load. So it's just, I find it easier to do that than try to go to the command line and start typing in stuff and hoping you get the right stuff to go. So just in general, I like to fall back on that, because you can also go, you can load that up and look to see what's installed on your computer. So if you just type in, say, Kinetic, it'll show you all the packages that are loaded for Kinetic, for instance. It brings all those up. It has a little green checkbox to tell you if it's installed or not. And that also gives you the version of each one at that point. So that's just a little hint if you start playing with that kind of stuff. What was the other thing I was going to point out? Oh, and since I couldn't get the RDS stuff to work, I was looking at the building stuff in Gazebo a little harder. And I think if I just sit down with some time, I can figure out, how to build, say, a little lawnmower vehicle, basically by just taking a bigger vehicle and trimming the size of it down. And I probably won't do anything fancy. I'll just start off with just a block for the chassis. And I don't know if you have to put an axle or if the wheels can just be floating in space, and it just says they're programmatically connected. I think you can actually just have 4 wheels, and they could be, you've set the origin so they're floating in space, and they're all still connected, so you don't really have to have a chassis, I don't think. But that way you could just go through and just have a parameter that says, here's my spacing between the wheels, and here's my wheel diameters, and here's the wheel width, and this kind of stuff. So you just change the numbers at the top and run it, and then you can, so you modify it for, slightly differently. So if somebody's got a different lawn tractor, you can just punch in the numbers. So we just have a list that says, if you got a John Deere Sabre, use this. If you got a Husqvarna 310, you put in this. If you got a Cub Cadet, whatever that thing is you have, you see, you can make it, at least get the dimensions set up correctly, so it would act fairly close to what you have. And then if somebody can figure out this CAD modeling thing, we could then get a fancy model and drop on top of it, so it looks like a real garden tractor. But you don't really need that to, when you first start experimenting anyway, you don't have to have that. If you're trying to show it off to somebody, it's nice to have it so it looks fancy. But and then once you get to that point, then you can add on things like the GPS module and the IMU module, and there's various things in Gazebo you can add on. And I was just looking to see if you could do that with some kind of include files. So instead of, because people usually just make one giant file with everything stuck in there, and then you say, okay, well, I want to set it up for something else. Well, now you got to go figure out how to trim all that down. So I was just wondering if you could say, just have an include file for IMU that would fix that, and an include file for GPS, so you can just start adding these things on to what you have. So I looked at that a little bit, and I need to get back to that and see if I can get that to go.
That's a really good idea. I've never seen an include file in a Zacro file, I think. I don't know if I have seen that before.
I think I looked far enough that it says you can do it, but I haven't actually tried it, so I don't know what it would take to do that.
That would be an interesting approach. And then you just have to adjust all of the transform dimensions, like you're saying, and then you could put it to anything.
Mm-hmm. So that way, if we can get Gazebo running and to the point we just load up a random vehicle into it, then we could either load the Husky or load our little tractor or whatever you want at that point. Because it's nice if you can do that anyway. You just say, you got a list of different vehicles, kind of like RDS, where they say, select, they got a list of like 10 or 20 different things. You can say, I want a quadcopter, or I want a Husky, or I want whatever. And you just load it up and sticks it in there for you. So that would be, if we could get at least some sample stuff. So if we're going to do, say, a big tractor and then do garden tractors, at least have one big one and one little one that people could play with would be handy to have. And actually, if it's configurable, they could be the same file, but you just configure it for the large tractor or the small tractor, and hopefully that would be close enough for people to use and get started with. So that's all I can think of at the moment. That, as I say, that's what I've been working on, and that's kind of the direction I'm going. I just need to get some time now to do it.
Yeah, lots of projects.
I see Sohin has moved inside now, so he's not out enjoying the weather.
My battery died, so
Oh.
I was on my phone. I had to rush in, get on a computer. But I was looking at, I got access. I mean, I was looking at the ROS Development Studio, and they're running everything on ROS Indigo and Ubuntu 14. So, have we tried that, or have we just tried doing it on 16?
We started all the stuff we did. We started with Indigo and Ubuntu 14.04, and all of our big tractors and everything was running on that. And just recently, we tried switching over to 16.04, partly because we said, okay, we're going to start this simulator project that we might distribute to people, and there's no sense starting with something that's going to be end of life in a couple of years. We might as well start with a fairly new thing. So that's why we said, okay, let's try 16.04. So I loaded that up on my virtual machines and then ran into the problem that it doesn't work with Gazebo 7, so I upgraded to Gazebo 9, and then they just fixed Gazebo 9, so hopefully it's fairly close to what I need now. But so we've run both, and for over a year we've run basically the simulator and real vehicles on 14.04 and Kinetic, or on Indigo, and now actually on the bigger vehicles too, because now we're switching over to the ARM-based processors that want to run 16.04. So that was another reason why we were switching there. So we're kind of moving ahead just simply because the boards we're buying need the newer operating system, and we thought, well, let's just do the simulator with the newer stuff too. So that's kind of the approach we're taking right now, and we'll see how far we get with that.
So, and when you say you're talking about Danfoss, or?
Yes.
Okay. So is Danfoss largely involved with using operating systems like ROS or like open source, or do they have proprietary software that they make use of as well?
Well, we're doing like a lot of people do. You start with ROS and do your development and all your prototyping, and then you say, okay, well, we want to take it out of the open source world and rewrite it from scratch and put it on something else. So the intention is we've got the small controller that goes on the vehicle. It's a box about this big. There's probably one laying right here somewhere. But anyway, here's one. So it's just a plastic box that has a lot of pins on. This is a 50-pin controller, and you put power and ground, and it's got 2 CAN buses, and then the rest of the pins are like inputs and outputs that you can drive solenoids and read sensors and so forth. So it's like having a microcontroller, and then they put buffers on all the I/O pins. So instead of just having a microcontroller with an output pin, now you got an output pin that'll drive 3 amps basically. So they just put a lot of the hardware into a common box. So now you can program this. They've got a graphical programming language where you drop down a block and you connect them together with little lines, kind of like Simulink or MATLAB or something, that type of interface. So now they want to create blocks to do, say, read the GPS and be able to load those into this controller. And say if we have a laser scanner, it turns out this thing doesn't have a big enough processor to process a live laser scan. But if you have something that converts it down and says, I see 3 objects out in front of me, then you should be able to handle that. So that's kind of the approach you're taking right now, is saying, how can we take what we've learned by getting an autonomous vehicle in ROS and then try to move it into something we can sell to our customers, something to provide them the ability to load the software in and then run their vehicle.
And this is ARM-based?
This one is, yes. And depending which one you pick up, they have. Some of the earlier ones used a TI DSP chip, I think is what was on it. But then they switched over to ARM, and I've seen ARM 2 and ARM 3 and ARM 4. And I think some of the newest ones, they're now looking at ARM7. So as they build the new boards, they just, you know, take whatever's the latest processor and try to design that in. And the other approach is they have display boards. So it's more like a laptop computer. It's an LCD panel, and then on the back they've got a board that has all of your electronics. And so since they're doing graphics on a LCD, they say, well, let's put Linux in it. So they now have embedded Linux in these displays. And then they put on bigger, they have like the IMX6 processor. I think that's what NXP puts that out. But it's a Linux-based processor. And depending which one you buy, you can either buy a dual core or a quad core processor to solder down to the board. And when they started building those, they weren't intending for us to try to put control software on there. So it was they just needed something that would talk to all interfaces and run the display and do that kind of stuff. So you know, it could be we can get to a point where we can say, well, let's put a more powerful processor on that board. But that way we have, you know, actual products that they're making to sell to the OEM market, and then we're just trying to figure out how to get our software to wedge into those and be useful. And the other day, that guy asked, he says, how many people are actually adopting ROS and putting out products with that? And you know, the only thing that came up was North Star Robotics, where they're doing their at one point they're doing a retrofit kit, so that you bolt this box onto your vehicle to be able to control your tractor. Now the stuff they're doing with the groundskeeping, the what do you call it, the golf course lawnmowers, I don't know if they're building their own machines or if they're just, again, doing retrofits for those. But that's you know, they seem to be charging ahead and using ROS on that. And there's lots of people in the industry, you know, not necessarily doing lawnmowers and tractors, but there's people that, you know, like Fetch Robotics, for instance, you know, they're big into ROS, and you know, they started out of the whole ROS community, so that's basically why they're going that direction, I think. And when the question was asked, I couldn't really think of, you know, people that are using ROS to do commercially released projects, but every once in a while you run into somebody that's doing that. If you look on the ROS wiki, you know, I look under there, you can find companies that are apparently doing real projects with ROS, and that's what they're shipping with it.
I've seen some robots. There are a few robots that use ROS, and I believe they also put one on the ISS back.
Robonick.
Yeah. Someone put a robot on the ISS in 2012.
I think it's Robonaut is what it's called.
Oh yeah, Robonaut. Yeah.
Yeah. So, these are all the robots that are out there who do use ROS. So interesting. Strobe are really small, so I believe there's a lot of robots who use ROS. Now we use ROS. I didn't know that. That's Robonaut.
Are you thinking you're displaying your screen? Because I don't see anything when you.
Wait, I sent links, but
Oh, okay.
I can display a link. I mean, display the screen too, but.
Well, I didn't realize you were. I see links are stacking up there, so yeah, I can click on those and see them.
Robot stuff.
And a lot of the robots they're showing there are like the research robots. So you buy it to do experimentation, and then the people like Fetch Robotics are actually, you know, building stuff to put in a warehouse to actually control things. And I don't know if they have a separate list for that kind of thing, or. And I think doesn't the Baxter robot use ROS, or am I just confused on that? That's that fancy one that. I guess at this point we just need one. We just need one tractor that runs ROS, and we can say, yeah, look at that. We've got a commercial vehicle that's running ROS. We need to get right on that.
So what are the steps missing right now for that?
For us to have a tractor that runs ROS,
Yeah.
well, someone has to have a tractor that is modified to be drive-by-wire. Then we have to put a computer on it, and then somebody has to. Well, the next thing you have to do is put sensors on, so you don't run over people, or you can tell where you are in the world. And then just a matter of picking and choosing packages to do what you want to do.
How big of an engine does it have to have?
You mean the physical engine on the tractor? Or you mean to run ROS?
No. To be considered a tractor.
A lot of it is, I think you have to look at the application, because nobody's ever seems to fully define, what they're going to do with this thing. They just want to. They think it'd be cute to take a tractor and have it drive around. And so on the other hand, Kyler says he wants to plant corn. So he started off with he's got 2 or 3 tractors, and he just started modifying those and started driving them out in the field. So he started with the application. He knew what he wanted to do before he started. And most people don't do that. They just say, well, let's build this tractor and people will buy it. If you build it, they will come. So so it's really just a matter, I guess, of, well, you still have the same basic concepts, whether it's a lawn tractor or a medium-sized tractor or a big tractor. You basically still have all the same control functions that have to go into it. So it's not as though you have to totally redesign it for the size of the vehicle. And then at some point you have to say you're going to add things onto it, like, I always forget the fact that if you're going to try to actually use it, say if you've got a planter on your tractor, when you start the row, you have to drop the planter down so it starts planting. And when you get to the end of the row, you have to lift it back up. And I see Kyler's got all that worked into his, because I don't know if he's got some extra scripting on top. But I think a lot of the stuff he's running is not ROS. He's just using the ROS communication structure. So he's said various times he just does straight line, or not straight line, but just things written in Python to do his individual functions. That he just passes messages around with ROS. But that's a whole other layer you have to add on top. Once you can get it so you can drive from point A to point B, and in a straight line, then you have to look at that and say, okay, what's the function you have to do? So if you're going to put implements on, you have to decide how you're going to control the implement, and you may need communication to that. Like, for instance, if you're driving down the field and you run out of corn, you don't want to drive for the next 3 hours planting when there's no corn in your corn planter. So you need sensors to do that. So a lot of it is you have to identify what you're trying to do and say, well, how do I know? And the easiest way to run into that is when you've planted for 3 hours and realize you didn't have corn. You say, okay, I need to fix that. But if you can think of that ahead of time and say, what's going to happen there? What if it breaks a chain? What if any number of things can happen there? And since I'm not a farmer, I don't know all the things involved, but I know I heard Kyler talking about hydraulic down pressure on each planter head. So there's fancy things there that could be controlled, or I don't know if he is controlling those. So, but again, basically you have to get a vehicle that can move and run on its own, and then you can add on, once you get to that point, then you have to say, okay, how am I actually going to use that? And I keep thinking that an interesting test, just if nothing else, just a thought experiment where you say, let's say our tractor's going to start out in our building, and we're going to have an alarm clock function. So 8 o'clock in the morning, it wakes up. It starts up, drives out of your building, drives down the road to your north 40s, goes through the gate and goes in and starts planting corn. If you think through all the steps on what would it take to do that, how do you know where you are? How do you make sure you don't run over anything? What do you do if somebody's coming down the road in the opposite direction? You have to figure all those things out. So just as a thought experiment, you can go through all the steps on that and say, what would it take to do that? And in order to know somebody's coming, you have to have sensors to do that. And in order, if somebody left something laying, if a tree fell down during the night, you have to be able to sense that. So that's something, if you're you're bored someday, you know, anything better to do, you can think through all the steps, what it would take to do that, and then you can think about, okay, what's going to happen if something goes wrong, and then you can start thinking about, you know, what if a tree does fall down? What do you do about it? And if you're driving down the road and somebody is driving down the middle of the road and you're trying to get past them, you know, you can think about, you know, what happens if that situation happens. You just pull over and stop and wait for something to happen, but that can go a long ways. You know, you don't even need a simulator to do that. You can just think through all the steps and say, well, you know, what do you need to make that happen? And then what are your neighbors going to think about that? Are they going to accept the fact that you've got this vehicle running on its own? And I know Kyler also has a story about, well, one time his tractor was driving across his neighbor's property and he wasn't real happy about that. So that's another situation. You know, you can think ahead and say, well, what happens if it gets to the end of the field and for some reason doesn't stop and keeps right on driving out into the next guy's field? So that's something else you can think about. How do you detect that, and what do you do about it if that happens? And in most cases like that, the simplest thing is just shut the thing down completely, and then you have to come back and decide what to do about it. So you have to physically go to the vehicle, and I think most people would probably be close enough to their vehicle. I see Kyler seems to have the approach. He's going to turn his vehicles loose, and hopefully they're going to do what he wants them to. It just seems like there's more things there that you could put obstacle sensors on. So if I realize you got this big 300-acre field, and there's no trees, no fences or anything. You can basically just say, do this repeating pattern where you drive up and down the field planting corn, and then when you get to the end, it comes to a stop. But there are situations, you know, what if there's a deer standing out in front of you, or what if you have a real big storm and it blows something, maybe blows it from the road into your field, so it's in the way. You should at least have something that can detect if there's an object in front of you. So because you don't want to run over it because the vehicle's not smart enough to know what that is, which brings up the problem if you live in the part of the country that has tumbleweeds. Well, you've got a tumbleweed that blows out in your field. Theoretically, you can run right over it, but is your vehicle smart enough to understand that that's just a weed laying there, that it's not really going to be a problem, as opposed to maybe somebody drove across your field and dropped a bale of hay out in your field. Maybe they're out stealing your hay, and as they came back, they dropped it in the middle. Well, you don't want to run over a bale of hay with your tractor, because that's going to be a big ordeal. So again, you have to decide, if you see anything in front of you, do you want to come to a complete stop and let the operator, you know, have it call you on the cell phone, and then you look at it on the picture and say, oh yeah, go ahead and run over that. That'd be one solution to get around that. Or you can just take the approach, I'm just going to just plow straight through and not even care if there's anything there. So there's lots of things there you can think about, and I guess a lot of that comes back to the when Bill was trying to start the minimum viable product. Well, you know, it seems like the minimum product is you need something that moves, and hopefully it's not gonna run into anything. So that's why you need to put sensors on to do that kind of thing.
I think image processing would be of great help, like, you know, image detection, like detecting and understanding what the obstacle is would play an important role, while, you know, in solving the problems that you just mentioned. Like, let's say if it's a tumbleweed, then the classifiers these days are really, really smart. And they can detect multiple things in just one frame. And the processors are so fast now that we can detect at 30 FPS or 60 even if if you invest more in that. So I think it's not about having minimum functions, but building it in terms of blocks. So we should have like one functionality working, have it go through waypoints, like using GPS, and then put that additional detection capability on top of that, and you know, add more functions on top of other things as we go. Because if we try to do everything that you just said, it's going to take us 5 years or 6 years or 10 years, I don't know, with a significant amount of work hours and, you know, lots of people working on it together. but we need to start that. And in order to start that, I don't think I've ever seen someone, except for Kyler, I haven't seen a big enough robot, like a robot that big, as big as a tractor, that does all that using ROS. It's interesting. I think Colin has something to show here.
Four-wheel steering, autonomous tractor.
Oh, nice. And
The tractor doesn't have the look at this. The tractor doesn't have the navigate it. Just
Is that Kloss's tractor, Colin?
sorry.
Is that a Kloss tractor?
Again.
Is that the Kloss prototype? Your volume is really low. I don't know if you can, down by the microphone, there's an up arrow, and then you can choose audio options. There's an up arrow right by the mute button or microphone button. If you click that up arrow, then there's audio options. Kind of an up arrow looking little icon. It's just a little teeny icon next to your microphone. You have a way to scan that book and upload it?
Or if it came from a web page, you could post the link to the web page.
Yeah.
That'd save a lot of scanning.
I thought I saw some videos of that tractor moving around. It's a four-wheel, but there's no cab on top. I thought I remember seeing some videos of it either planting or driving through a field, but I don't remember who that was from.
I think it's possible. It's just it needs a lot of people to do it, our time.
So I just posted a video that probably is the same one he's got there. It's a YouTube video. It kind of looks the same type of vehicle. Yeah, that's the same one. So that does bring up the question when somebody goes to do this, you've got two options. You can start with an existing vehicle and modify it, or you can build your vehicle from scratch. So it looks like these people just started from scratch to build this one. So a lot of that is you have to decide where do you want to spend your time. A lot of it depends on, do you like building mechanical stuff, or would you rather just get something quickly modified and then get it to, say, move on to the software. So depending what somebody's approach is, they may want to do it one way or another.
Is this a differential drive?
I think it's a double Ackerman.
Oh.
So it looks like it has some fairly exotic steering on it, since it can, one of those things that can go at a 45-degree angle sideways, or which brings up another point. You know, if you're going to design this, do you want to get into creative steering, or you just want something that's well tested and will drive straight down the field? So that again is where you have to look ahead and say, what are your applications, and do you need to have the fancier steering or the non-standard steering on something like this?
I think developing a vehicle from scratch is a big task.
Looks maybe just Ackerman, right? I don't know if those back wheels are turning.
Well, that diagram you just held up showed the front wheels and the back wheels both seem to be steerable, and it looked like instead of a normal double Ackerman is where the front wheels would turn left and back wheels would turn right, and then you'd go in a circle. But here it showed them both turning. Both I don't know how to explain that, but that one diagram he held up, it looked like the front wheels that turn left and the back wheels that turn left, which basically means you're going to go with kind of the whole vehicle is kind of go sideways.
Crab.
Yeah, something like that. And that brings up the question: do you really need to be able to do that or not? So that just adds another level of complexity of trying to figure out where you want to be and how to get there. But if you design it like that, then you can always just leave, say, the back wheels always pointed forward, so you can have the option to play with it if you want to. But it's just easier to disable it and say don't turn the back wheels. So you'd have the option to go either way then. And if you are developing your own vehicle, then you've got the question: do you want it to be a hydraulic transmission or an electric drive vehicle, or, so again, you have all these different options. That's why sometimes it's easier, depending on what you're trying to do. If you just start with a vehicle that exists, like say Sohin on their group, they just got that little golf cart type thing and started modifying that, so they didn't have to build that from scratch. So they just started with something. And that's why at one point I suggest you just start with an old car and use that to modify, because you can get them anywhere. And it might be a little more acceptable in town to have that parked in your driveway than have a big tractor parked in your driveway. And that's why I was trying to build something small like a lawnmower, so I don't have, number one, I don't know where to put it, so it's just easier to get a smaller vehicle, and I don't have much room to run it. So it just seemed more logical to do that, either start with a lawnmower or build my own something smaller than that. And part of it is I like building stuff from scratch, and that's why I lean towards doing that as opposed to, say, just going out and buying a brand new lawnmower to modify. So a lot of it's just your approach you want to take.
In my experience, it takes several. You can't get it right. If you're building your own vehicle, you never get it right the first time. You have to build it and then rebuild it and then rebuild it the third time, and then you might have something going on. And this takes a lot of time. So if your goal is to build a great tractor that can be turned into autonomous, you would succeed, but you won't be able to build an autonomous tractor. And that's just what I've learned. I think it saves a lot of time to just get a vehicle and then get a vehicle that needs minor modification. Do those minor modifications and get your teleop working. Once you have the teleop working, then you have control over your robot, and then you can start building on top of it. Try to make it go by waypoints, and then you can slap some sensors on it. I wouldn't ever want to build a vehicle of my own. It takes a lot of people to build a tractor. I mean, these companies have like 80,000 employees trying to make it right and make it commercial.
The other thing is, if you decide up front that it doesn't have to be pretty when you're done, that cuts out a lot of the work right there too. So if you're just willing to start slapping stuff on and using duct tape and hot glue, and you can move ahead pretty quickly, whether you're creating something from scratch or modifying something. But if you decide up front, it's got to look nice when we're done, then you spend a lot of time trying to work around that too. So
I wouldn't care if it looks ugly, but I wouldn't care if I would be able to do it again. That's the more important thing. And being able to document everything over as you keep doing. I don't think building a vehicle is a one-person job or even a small team's job. That is the only reason why, because our team made a small vehicle. It was completely custom made. I don't know if you have seen it, but it looks like a small Mars rover. It has an Ackerman drive and everything. They designed the Ackerman drive themselves. They designed everything, and it is not reproducible. It takes so much work to make it again, and we haven't done it. That's the only reason why. Because there's when they were doing it, they did do some designing and everything, but a lot of that knowledge gets lost over time, and whoever built it, if they're gone, then you lose that chunk of knowledge, and that is the hard part.
So it looks like we've expired our hour's time here. So thanks to everybody for showing up. And I'll have to quiz Matt on what I have to do about this recording here. I guess I'll stop the recording, and then I don't know. I don't even know where that ends up. So here, I'll go ahead and stop it now if I can.
Have you heard of mechanical